I had a question about 13b from the long response practice problems. And this manipulation, the part B asks you to work with a central model for chapter 2. So chapter 2 builds this story carefully, and this question asks you to put all the pieces that were described in chapter 2 together. And so let's go dive into that. So this article talked about how the taxi industry has just been shrinking because of the emergence of Uber and Lyft. And let's tell that story in terms of our model. So here, the way we'd model this is to think of, we'll just simplify the world to focus on ways of offering some quantity, let's just say 100,000 miles of hired car travel in New York City. So that's our fixed output. And the way we represent technology is, okay, there's going to be only two factors. Let's say taxis, and this will be, that's an X, believe it or not. This will be taxi hours per week. We could pick any time unit we wanted. And then these are private cars. I did it again. And again, private car hours per week. And the way we represent technology, okay, there's these various combinations of taxis and private cars that could offer this quantity. And let's say you could have a large fleet dominated by taxis. We'll call that point E. I think I'm mimicking the notation in the book for making 100 square meters of cloth. Let's say there's some point B that's a combination. I want to draw that just a little differently. Let's say there's point B that's a mix of taxis and private cars, and let's say there's this point way up here that we'll call A. And let's say in the year 2000, prices are such that let's have a new color for isocosts. Prices are such that taxis are relatively cheap and private cars are relatively expensive. And remember that the slope would be negative PT, the price of a mile hired of taxis, and then we'll call this PC, cost of a mile of travel in a private car. That's the slope of that isocost. And we'll call this IC 2000. And we'll call that's an isocost in 2000. We'll call this IC1, just for kicks. And we noticed that at these prices, having a bunch of taxis and not many private cars, that's what point E is about. It's a very taxi-intensive way of offering hired travel. T naught and C naught. That's the lowest cost way. If we were to think about point A, say at 2,000 prices, we'd be thinking about some isocost line at 2,000 prices. We'll call it IC2 and 2,000 prices, and E is just a lower cost way of doing things. Well, with the emergence of cell phones, there's other possibilities, and as we talked about in class, these possibilities aren't necessarily immediately realized, but when prices change, what happens is that there are opportunities created to earn innovation rents, and these rents will incentivize. I hate that word, but it means something that other words don't, so I'm going to use it. And anyway, that provide the incentive to private innovators to think of other ways of offering hired cars. And let's use a different color for 2017. Let's use orange. And by 2017, there were, let's say by 2015, 14, whenever the pre-Uber world, there were, the taxis has gotten more expensive, and or I think in particular, managing a fleet of private cars by means of the internet and apps and cell phones had become much cheaper. So initially people hadn't sort of thought it through and didn't take the opportunity to rethink how they offered private car travel. So we're still at E, but at these much different prices, much different relative prices for taxis and private car use. So the slope there is PT prime, some higher price at taxis maybe, or even if it's constant, and that would be over PC prime. And the big event here is the fall in cost of managing a fleet of private cars. So now there's this innovation rent possible, and innovators could come along and offer private car travel for getting around New York City or other places. And now the innovators would be offering the car travel at a point like A, where the mix is skewed toward offering private cars and much fewer taxi cab miles, and so the shift from IC1 2017 to IC2 in 2017, that distance, that fall in costs, that's the innovation rent that accrued to the innovators at Uber and Lyft, and maybe Juno, and maybe Lyft, not Uber. We'll see. It's sort of dynamic. It's playing out right now, and that's that story. The big difference between this question and number 14 was not the manipulation of the model. It was instead part C. In the case of taxi drivers, we can easily see them being absorbed by Uber and Lyft as Uber and Lyft drivers, Uber and or Lyft drivers. The 14, I'm not going to go through 14 because the graph and the analytics would be exactly the same. We just have to relabel the axes for humans on the x-axis and robots on the y-axis. If for 14, this would be humans instead of taxis hours per week, and this would be robots hours per week. But the technical analysis would look exactly the same. And instead of ways of offering 100,000 is what I meant to write, right? 100 miles isn't very many, but 100,000 starting to be some real miles traveled. That's correcting a typo. Anyway, I said it right. I didn't write it right. But when we get to the Amazon case, the difference is in part C. What do you expect will happen to displaced human factory workers? Well, that's not so clear. What are those humans that used to work in the factory going to do? The robots are taking their jobs. There's just not a need for human workers in factories. The increase in factory work to absorb all those displaced humans would just have to be fantastically big. Maybe we'll see that, but if we're thinking about humans having to find other work, what's that going to look like? Is it going to be waiting tables at much lower incomes, or will it be writing new apps at higher incomes? The fate of the well-being of much of American population sort of hangs in the balance of how that question will be answered in coming decades.